All right, we've been working with parallelograms. So the next thing that we do are rectangles. Let's look at that family tree again. In parallelograms, we learned 5 properties. And we're going to take those 5 properties and we're going to bring them with us to rectangles. And then we're going to add 2. So we're going to end up with 7 properties total. It's really important that we know those 5 properties of a parallelogram. So let's review those, and we can keep all of our properties in one place for each shape. So a rectangle is a parallelogram. So let's review those properties of a parallelogram. We have both pair of opposite sides are parallel. Both pairs of opposite sides are congruent. Both pair of opposite angles are congruent. Consecutive interior angles in both directions are supplementary. And then we've got the diagonals, both of them bisect each other. So you can see the word both is a theme in these parallelograms. Everything comes in pairs. Well, we take the 5 properties of a parallelogram, and to turn it into a rectangle, we add 2 things that we probably already knew already. These diagonals are going to be congruent, and now we have 4 right angles. So a rectangle is really a parallelogram that stands up straight. Right angles. We can see the properties all put into the picture. And just like before, we want to notice what we can. We're comfortable with triangles. We know a lot about triangles. So think about what can we identify about these triangles that we see. Well, since we have congruent diagonals and the diagonals were bisected, then all 4 parts are congruent. So look at the diagonals were congruent, but then they're also bisected. So we actually have 4 isosceles triangles. And the opposite triangles are congruent by SSS. So in a parallelogram, we had 4 scalene triangles. The opposites were congruent. In a rectangle, we have 4 isosceles triangles. The opposite triangles are congruent. An important observation. It can really help us if we remember all of our properties about congruent triangles. Okay. So having all the properties in one place. Let's solve a few problems here. We are given some information to start, and that information, we want to get that into the picture. So angle RPS is 62. That's already filled in. and then segment QS, the entire diagonal. So this is a diagonal. The whole thing is 18. Now, we don't want to overload the picture, but we do want to understand that. So let's see what we can do here. Number 17, angle QPR. QPR. Let's find it. QPR. And how are we going to do that? Well, since it's a rectangle, we know that each corner is 90. So we're looking for that little angle. 62 plus angle QPR equals 90. And we can find out that it's 28 degrees. I'm going to erase that and clean things up a little bit. Next question, we're looking for angle PTQ. So again, I want to find it. PTQ. So we're looking for this angle right here. Well, again, we knew that 28. So let's build on that. Let's just isolate the picture here. PTQ 28 degrees. Now we're looking for that angle. Think about the properties of a rectangle. In a rectangle, the diagonals are congruent, but the diagonals are also bisected. So all of these parts of the diagonals are congruent. We observed that it was an isosceles triangle. That's very important because it's in an isosceles triangle, the base angles are congruent. So we can say 28 plus 28 plus our angle PTQ, which I put a Y, equals 180. So with a little quick math, we find out that our angle here is 124 degrees. I'm going to go back and erase this and start clean for the next question. We're asked for ST. Well, the diagonals bisect each other. So half of 18 is 9. And for number 20, PR, the diagonals are congruent. So if SQ is 18, then PR is 18 as well. Diagonals are congruent. So applying the properties of a rectangle, the same 5 properties of a parallelogram, plus each corner is 90 degrees. We have right angles. And the diagonals are congruent. Okay. I think that is it for rectangles.